All right, welcome to the first of our series of videos for the book. So this is chapter 2, and yeah, I'm starting at chapter 2. Chapters R and chapter 1 should be review for most people, and even if it's not review for you, as some of you have suggested, please, there's plenty of support material online. And I just need you to look at that. So we are essentially starting out at chapter 2. So accept that, please. And I know we have a big homework for chapter R. Well, the orientation questions on the website, chapter R and chapter 1. Big homework, meaning it has a lot of problems on it. And some of them were not trivial. I know, like, some students were asking me about very, very specific topics like synthetic division. And that's why, and yeah, some of those are worthy of a little bit of a description. But for the most part, if you're not getting something in those earlier chapters, I want you to do a little research on your own. Not research, but use the assets of the website for those. I just don't think the class would benefit from me or anyone else going over adding a fraction or whatever, exponents, some of those ideas that might have been covered in earlier sections. All right, so chapter 2, section 2.1, the distance formula and the midpoint formulas. And I have a few other things to say about this, so it's not just the distance formula and midpoint formula. In other words, please don't tune out if you already know the distance formula and the midpoint formulas. Objective, use the formulas. And here's what I want to add to this. I want to say we're going to use the distance formula whether we have a picture or not. So the distance between 2 points might be fairly easy to spot if you have a picture and you could measure the distance between the 2 points. But if the numbers are really big or really awkward, I mean, they would be hard to draw. But you plug them into the formulas and you can calculate them. So we're going to talk a little bit about geometry versus algebra, or geometry versus arithmetic. And sometimes it helps to have both. All right. So here's the distance formula. You'll see it anytime you have a problem with the distance formula. You can just kind of click on the help and it will show you this. But we have 2 points. We're calling one point, x comma y. So x1 comma y1, x2 comma y2. And the distance is this formula. It's the difference in the x values. Elsewhere we call this change in x. And the change in y, delta y. All right. So if you have the change in the x value, square that, change in the y values and square that, you'll get the distance formula. By the way, it's almost always written this way with the y2 minus y1. And here's a tip. It doesn't matter if you had, 5 minus 3 and squared it, versus 3 minus 5 and squared it. The only difference is what's inside, one will be negative and one will be positive. But if you square it, here you're squaring positive 2, here you're squaring negative 2, you're going to get the same number, the same value. So I think of squaring kind of acting like absolute value, and absolute value essentially is saying, you know what, it doesn't really matter what the order is. I only mention that because some students will say, well, I did it with, x1 minus x2 and it worked. Should I change it? You don't have to change it. It's going to be fine. All right. But like I said, most books will do x2 minus x1, y2 minus y1. So if you want to follow along in a book or a presentation, just keep that in mind. All right. So, squeezing the formula in here. X2 is 1, so a 1 goes there. x1 is negative 4. Yeah, y2 minus y1, all under the square root. And it works out to be the square root of 29. Square root of 29 is very important, by the way. We call that the exact answer. And we almost always want the exact answer. Even if we want an approximation, the answer immediately before the approximation should be the exact answer. So exact answers are the preferred way of getting an answer. Now, when some students hear approximation, sometimes they think that they can make it exact by adding more decimals. No. So sometimes I prefer a different name for the exact answer. Sometimes I prefer calculator ready. I want something I could put in my calculator, and I can't put in my calculator 5.39, and if you gave me 10 more decimal places, 385 something, it wouldn't really help. I could put square root of 29 in my calculator. So exact answer means something calculator ready. Approximate, an approximation is just giving this number, whatever number of decimal places are requested. So earlier when I said I'm going to talk about something that wasn't directly related to the distance formula, this is what I was talking about. If you're asking for exact answer, give something calculator ready. Now, if that had said the square root of 36, you'd finish it. The answer is 6. So sometimes the exact answer is simplified. But if you can't simplify it without a calculator, give me the answer with that's calculator ready. That's what everybody wants. All right. So this is a pretty big problem. Just a lot of parts to it. But they asked us to consider these 3 points and basically plot them to form a triangle. So we're going to plot these 3 points. It's going to form a triangle. We're going to use the distance formula, apparently, or whatever method, to find the length of each side of the triangle. And then this, we want to verify the triangle is a right triangle using the Pythagorean theorem. A squared plus b squared equals c squared. That's how we're going to verify it's a right triangle. In other words, we're not going to verify it's a right triangle by measuring it with a protractor. And then finally find the area of the triangle. There's a formula, 1/2 base times height, that we're going to use to find the area of the triangle. All right, so here is those points plotted. If you don't remember them from the other side, here they are. A is -1, -3, 1. B is -3, 4. C is 4, 1. And I'm using some formula. Now, remember, they're saying using algebra to solve a geometry problem. I'm using notation from geometry where the length of a segment is just named AC. Now, in algebra, the author won't use this. AC sounds like A times C, but in geometry, it's the length of this segment. And it's 7. I did not just use the distance formula. I just counted 1, 2, 3, 4, 5, 6, 7. So sometimes geometry is good for finding certain things. If I count this way, I'm lining it up here. 1, 2, 3. Side AB is 3. And that's great, but what's this one? All right. I know these sides, but I can't really find this one. I could try to measure it, maybe guess what it is. I know it's longer than 7, because if we're 7 exactly, wouldn't quite, wouldn't be the longest side of the triangle, but don't really know much more about it. So, from geometry. So, algebra is going to be necessary. And you can see what the author did. AB, the author did calculate that. The author uses this notation for AB, distance from A to B, substituted appropriately, and got 3, as we saw on the other page. AC is 7. So we knew that. But the one we couldn't figure out just by looking was BC. So we need something. The distance formula. We put in the correct substitutions and we get the exact answer, and I went ahead and gave an approximate answer. But notice the author stopped at the exact answer. That's pretty telling. Exact answers are so important that the author didn't even bother giving us this other one, the approximation. All right, we found, part B was to find the length of each side. Part C is to check to see if it is, in fact, a right triangle. Well, 3 squared plus 7 squared, does that equal the square root of 58 squared? And I put a question mark here. There's no variable. I'm not trying to solve for anything. I just want to substitute all 3 numbers and calculate. Is it true that 9 plus 49 equals 58? Yeah, I get 58 equals 58. So what does that confirm? It confirms that something squared plus something squared equaled the other side squared. C squared. And that means it's a right triangle. So it follows by the official name is the converse of the Pythagorean theorem, that it's a right triangle. That was a little bit of geometry we just used there. All right, I said this was a long problem. So this is that same problem with those same values. And now they want us to find the area. So the formula for the area of a triangle is 1/2 base times height. And, well, here's a good question. What's the base and what's the height? Well, any measurements that are perpendicular can be the base and the height. It doesn't have to be this way. I could have called this one the base, and I could have called this one the height. But if the 2 measurements are perpendicular, they qualify as one of them being the base and one of them being the height. So notice I can't use this one, the square root of 58. It's not perpendicular to anything, so it would be a bad measurement for this particular formula. Looks like, well, let's use the one I circled here. If I call this the base, that would be 3. That's what the author did. And if I call this the height, they just have to be perpendicular. That would be 7. And you substitute that and you get 21/2 square units. And this is telling. I mentioned earlier, calculator ready. We even do that with fractions. What I mean by that is, unless they specifically ask for decimals, we prefer fractions in algebra. 21/2 is not a surprise to me that's what it would do. If I wanted to grab my calculator and do 21 divided by 2 and get 10.5, which isn't an ugly number by any means, but it's just not the number we're looking for. So, and by the way, both of these are exact. It's not just not an ugly number, it's the same number. So I guess this would qualify as exact, but it wouldn't qualify as calculator ready because you can't calculate 10.5. It's already calculated. This is 21 divided by 2, and that's why I sometimes like the description calculator ready as a better description of exact answers. Midpoint formula. Remember, the midpoint formula is a point. So the parentheses are required. You can't have a point without parentheses and the comma. And basically, this is just the average. Notice it's a plus sign. It's the average of the x and the average of the y's. That gives you the midpoint. So on this one, the average of the x's, well, the average of -4 and 4 is 0, and they did the calculation, to show that, to punctuate that, I guess. And what's the average of 4 and 2? Well, to find the average of 4 and 2, you add them up and divide by 2, and you'd get 3. So putting that all together, the midpoint average of the x's, average of the y's, I get 0,3. So they went ahead and did that here. This was the first point, this was the second point, and the midpoint is the point right in the middle. Now, this would have been really hard to do without, not really hard. I think you might have guessed that that was the answer without, the formulas, without algebra. In other words, if I just gave you this picture and said, what's the coordinates of the middle point? If I can't really do this, can I? Let's get black here. And, well, yeah. What if that was not there? Everything else in this picture was there, but that wasn't there. Could you tell just by looking that that ordered pair is 0,3? I think maybe, but 0,3. But I don't know. There's just something reassuring about calculating the midpoint. And if I tweak this just a little bit, you can see how fractions and other things could come up in this, and you really do need the formulas. So don't get, I don't know, lazy thinking you can just see the answer. Make sure you know how to do it in another way. That would take us to section 2.2, which I'm going to put up on another video because I want to keep these videos, under a certain time limit, so they upload easier, really. But also so they're easier to navigate when you watch them. So that was section 2.1, and for 2.2, check the next video. I'll see everybody then.